So hello guys, once again I welcome here all of you in this marathon session of highway engineering. Yesterday I'll discuss with you the numeric portion of highway materials. Today we're going to discuss the previous year questions of highway materials. Okay, today we're going to discuss previous year questions of highway materials. Okay, so our first question is from gate 2021, gate 2021 of 2 marks. This question is asked in set 2. So what it is, in an aggregate mix, the proportion of coarse aggregate, fine aggregate and mineral filler are 55%, 40% and 5% respectively. The values of bulk specific gravity of coarse aggregate, fine aggregate and mineral filler are 2.55, 2.65 and 2.70. So the bulk specific gravity of aggregate mix, that is GM, is, so as we already know the formula of GM, so we'll calculate GM is equal to our weight of total weight 55 plus 40 plus 5. Basically it is given in percentage, 55 plus 40 plus upon 5 plus 5, and our weight upon specific gravity. So 55 upon 2.55, 55 upon 2.55 plus 40 upon 2. Yeah, 2.65 plus 5 upon 2.70. 5 upon 2.70. Okay, if we calculate all of these things, so 55 plus 40 is 95 plus 5 is equal to 100, and 55 divided by 2.55 is 55 divided by 2.55, it is equal to 21.56 plus 40 divided by 2.65, it is equal to 15.09. Okay, plus 5 divided by 2.70, we'll get 1.85. Okay, if we add all of this, 21.56 plus 15.09 plus 1.85, we get 38.5. We get GM is equal to 100 upon 38.5. So if we divide 100 from 38.5, we get 2.59. We get 2.597. Okay, so here GM is equal to 2.59 in, as it is asking out of 2 decimal places, so correct answer is 2.59. Okay, so one more thing, in a gate examination there is a virtual calculator. So before gate examination, do practice that virtual calculator, because it will be very hectic if you didn't practice that. Okay, so do that before your gate examination. Let's move forward to our next question. This question is from gate 2022 of 1 mark question, which will asked in set 1, and another question of gate 2021 which is also 1 marks, and this is asked in set 2. So this is both of these questions is from theoretical portion. As I already told you that do prepare all your theoretical portions from your book or any other material which you prefer, because in particularly in higher materials there is a lot of question from theory theory part. Okay, but we will discuss only the numeric portion in our previous video of highway materials. So do your theoretical portions from your book or any other material. Okay, because a lot of questions from you'll see in highway materials from theoretical portions like this. This question is, the Los Angeles test for stone aggregate is used to examine, basically there's a test in highway materials which is named called the Los Angeles Aberration test. So 100% this answer is B. Okay, B, which is aberration resistance. The sorting point, and another question, the sorting point of bitumen has the same unit as that of, basically sorting point of bitumen has the unit of degree Celsius, that is same unit as of temperature. Okay, let's move forward to our next question. Basically both of these question is again from your theoretical portion. Okay, look, here's this question is from gate 2018 1 mark question which is asked in set 2, and this question is 3.34 which is asked in 2019 1 mark question in set 2. Okay, so this question is, the initial concavity in load penetration curve of a CBR test is not due to. Okay, Here is it is asked that initial concavity of in the load penetration curve of CVR test is not due to. Before that, we'll discuss that the initial concavity in CVR test is due to, basically it is due to improper compaction, improper compaction due to soft top layer, due to inclined plunger, due to inclined plunger, due to uneven top surface, uneven top surface. Okay, uneven top surface. Do remember this, that the initial concavity of CBR in CBR test is due to improper compaction, due to soft layer, due to inclined plunger, due to uneven top surface. Okay, let's move back in our question, that the initial concavity in load penetration curve of CBR is not due to. So here we discussed right now that the initial concavity in load penetration curve of CVR is due to the uneven top surface, is due to, oh wait a second, I'm here. Yeah, so initial concavity in load penetration curve is due to uneven top surface, is due to inclined penetration plunger, due to soft top layer. So there is a remaining one option, high impact head start of loading. So this is the correct answer, that is option B is correct answer. So our next question, if the fineness modulus of a sample of fine aggregate is 4.3, the mean size of particle in sample is bit B. Okay, before that, let's see one thing about sieve, that as per IS 2386, as per IS 2386 of part 1, of 1983, in 1963, I'm sorry, 1963, that there is, we have a sieve like 150 mm of sieve, 300 mm of sieve, 600 mm, 1.18 mm, 2.36 mm, 4.75 mm, 10 mm, 20 mm, 40 mm, and 80 mm. Okay, so we have sieve of like this, and in this question, basically the finest modulus can be regarded as weighted average size of sieve on which material is retained, and the sieve being counted from the first sieve. Okay, and in this question, the finest modulus of 4.3, 4.5 modulus of 4.3, so it's indicated of size 1 2 3, indicated of size fourth and fifth sieve. Okay, that is 1.18 and 2.36 mm. So our correct answer is 1.18 and 2.36 mm. Let's move forward to our next question, which is that a bitumen sample has been graded as VG30 as per IS 73 2013. The 30 in the grade means that, again this is a theoretical question, bitumen sample has been graded VG30 as per IS 73 2013. The 30 in the grade means that, viscosity of bitumen at 60 degrees Celsius is between 2400 and 3600 poise. Okay, so this is our correct answer. Let's move forward to our next question, which is of GATE 2017 2 marks question, which is asked in set 1. Okay, so what is our question? Basically our question is, the following observation are made while testing aggregate for its suitability in pavement construction, and it is given that mass of oven dry aggregate in air is 1000 gram, and mass of saturated surface dry aggregate in air is 1025 gram in air, and mass of saturated surface dry aggregate under water is 625 gram. Okay, let's say, and based on the above observation, the correct statement is, so we need to give the correct statement. Okay, these are from A, B, C, and D. Let's say this is equal to A, this is B, and this is C. Okay, and we already know the formulas, that bulk specific gravity is equal to A upon V mix, and apparent specific gravity is equal to A upon V. We write it also as, from here, A upon B minus C, and apparent, we also write apparent specific gravity as A upon, yeah, A minus C. A upon A minus C. Okay, so that is WA, that is A upon, that is 1000 upon, that is 1000 upon B minus C, that is 1000 upon B minus 3, that is 1025 minus 625, 1025 minus 625. So if we calculate this is equal, if we calculate this, 1025 minus 625 will get 400. So if we divide 1000 from 400, we'll get 2.5, and same here, 1000 upon 1000 minus 625. So yeah, 1000 minus 625, that is 375. If we divide 1000 from 375, then we'll get 2.66, 2.67 approx. Okay, so we'll get our 2.5 and 2.67, but here it is asked water absorption. We have bulk specific gravity of 2.5, here also 2.5, and apparent specific gravity of 2.6. That is, it is confirmed that both of this answer is wrong. Let's move to calculate water absorption. So we have water absorption formula. Water absorption, that W upon WA into 100. If you look at this, that this is equal to B minus A upon A. Okay, so we can also write it like B minus A upon A into 100. Okay, that is B. B is equal to 1025. B is equal to 1025. A is equal to 1000. C is equal to 625. So B 1025 minus 1000 upon 1000, that is 25 by, sorry, Let's move this from here. That is 25 upon 1000 into 100. So that is 2.5 is our correct answer. It is in percentage. Okay. So our correct answer is option A. Yeah. So this is it of this question. Let's move forward to our next question, which is of GATE 2016 of 1 mark question. That during a forensic investigation of pavement failure, an engineer reconstructed the graph P, Q, R, and S using partial damaged old reports, and that engineer construct graph of these graphs. Okay, so theoretical plausible correct graphs according to Marshall mixture design output are, if you watch my previous video of highway materials, which I uploaded yesterday, you'll get there. I already told you that there's a lot of question from graphs also. Okay, and I already told you that there is a one question of 2016, and that question is this question. Okay, so here it is asked that theoretical plausible correct graph according to Marshall mixer design output are. Okay, if you remember those graphs, this graph is correct. Okay, and this graph is also correct, and this graph is also correct, but here this graph is not correct. Basically in this graph is something like this. Okay, not like this. So the theoretical correct graph is option P, Q, and S. Option B is our correct answer. Okay, let's move to next question, which is asked in 2015. This is 2 marks question, and it is asked in set 2. So that basically this is a kind of a match following question. Here it is asked resistant to impact, resistant to wear, match column group 1 with group 2, resistant to weathering action, resistant to crush. Look, resistant to impact, that is, it determine toughness. It is related to toughness. Weathering action related to soundness. If you see, that is P is oh shit. P is related to P is related to third, and R is related to fourth. P to third and R is fourth. So obviously our correct option is B. Yeah. And yeah, resistant to wear. So resistant to wear is for hardness, and resistant to crushing is for strength. Okay. So this is it. Let's move to our next question. Before that, let's zoom it. Yeah. This question is asked in 2015 in set 2, and this question is asked in 2015 in set 2. Look here. In 2015 set 2, there is a 4 marks question from highway materials. 2 from this, 2 of this question. That is 4 marks, which is use weightage in 2015. So here the 27th question of GATE 2015, that the penetration value of bitumen sample at 25 degrees Celsius is 80. Okay, and when the sample is heated at 260 degrees Celsius and tested again, the needle of the penetration test apparatus penetrates the bitumen sample by dmm. Okay, and the value of d cannot be less than. Okay, so before that, let's see a relationship between penetration and temperature. Relation between penetration and temperature. P is equal to AT plus K. Here P is penetration, A is temperature susceptibility, and K is constant. Okay. So with remember one thing, with increase in temperature, penetration increase. As temperature increases, penetration increases. So this will imply simply we say that button that is D not should not be more than 8 mm. Okay, that is D should not be more than 8 mm. This is it from this question. So let's move to our next question, which is asked in gate 2015 of 2 marks set 2. This question is that in Marshall method of mixed design, the coarse aggregate, fine aggregate, fines, and bitumen having respective value of specific gravity 2.60, 2.70, 2.65, and 1.01 are mixed in the relative proportion percentage by weight. That W1 is 55, W2 35.8. Basically, this is G1, G2, G3, and G4, and here W3 is 3.7, and W5 is 5.5. All of this in percentage. The theoretical specific gravity of the mix and the effective specific gravity of the aggregate in the mix relatively are. Okay, basically we have, if remove this all these things, basically we have data that G1, G2, G3, and G4 is equal to 2.60, 2.70. G1 is equal to 2.60, G2 is equal to 2.70, and G3 is equal to 2.65, G3 is equal to 2.65, and our G4 is equal to, that is specific gravity of bitumen, G4 or GB is equal to 1.01. Similarly, we in percentage, W1 is 55%, 55%. W2 is equal to 35.8%, 35.8. W3 is equal to 3.7, and W4 is equal to 5.5. W3 is equal to 3.7, and W4 is equal to 5.5%. As we already discussed that formula, GT is equal to W1 plus W2 plus W3 plus W4 upon W1 by G1 plus W2 by G2 plus W3 by G3 plus W4 by G4. Okay, so GT is equal to loan W2, W3, W4, add all of these things, that is 55 plus 35.8 plus 3.7 plus 5.5, that here 55 divided by G1, 55 by 2.60 plus 35.8 divided by 2.70 plus 3.7 divided by 2.65 plus 5.5, wait, 5.5, 5.5 divided by 1.01. So if we calculate all of these things, GT is equal to 55 plus 35.8, at 55 plus 0.8 plus 3.7 plus 5.5. Wait a second. Plus 5.5. It is equal to 100. Okay. If we divide 55 from 2.60, 55 divided by 2.60, we'll get 21.15. We'll get 21.15 plus 35.8 divided by 2.70. It is 30.25, 13.25. If divide 3.7 with 2.65, 3.7 divided by 2.65, it is 1.39. 39 plus 5.5 divided by 1.01. It is 5.44. Add all of these things. That is 21.15 plus 13.25 plus 1.39 plus 5.44. It is equal to 41.100 divided by 41.23. 41.23. If we divide 100 from 41.23, we'll get 2.425. We'll get value of 2.425. That is GT is equal to 2.425. GT is equal to 2.425. Okay, this is value of theoretical specific gravity 2.42 in all of these three options. 2.42, 2.42, 2.42, and in last option D is 2.64. So D is not correct. We have to choose from A, B, C. 2.42, 2.42, 2.42. Let's calculate effective specific gravity. So effective specific gravity have formula. It is effective specific gravity of effective specific gravity of aggregates. Okay, so aggregate, that is coarse aggregate and fine aggregate. So we have here formula W1 G1 plus W2 G2 upon W1 plus W2. That is G dash is equal to 55% into 2.60 into 2.6 plus W2 is 35.8 into 2.70. 35.8 into 2.7 upon 55 plus 35.8. So if we'll calculate this, that 55 into 2.6 is equal to 143. G dash is equal to 143 plus 35.8 into 2.7. It is 96.66. 96.66. 96.66 upon 55 plus 35.8. It is 90.8. 90.8. Here 143 plus 95.66. It is equal to 238.66. So 238.66 upon divided by 90.8 divided by 90.8. It is equal to 2.628. It is equal to 2.628. So if we see 2.628 approx 2.63 answer. So option A is correct answer. Okay, let's move on. Our next question, which is asked in GATE 2014 of 2 marks in set 2. In a Marshall sample, the bulk specific gravity of mix and aggregate are 2.32, 2.546 respectively. The sample includes 5% of bitumen by total weight of mix, okay, of a specific gravity 1.10, the theoretical maximum specific gravity of 2.41. Okay, the word VFB, we need to find VFB in the mass sample in percent. Okay, read again this question. In a mass sample, the bulk specific gravity of mix and aggregate, here it is GM. Okay, the sample includes 5% of bitumen by total weight, it is WB or W4, and specific gravity it is GB or G4. The theoretical maximum specific gravity of mix, it is GT. Okay, and we need to calculate VFB. So we already know that our formula VFB is equal to VFB is equal to, we have formula before VFB, we need to calculate, we need to put all the values we have. We have GM is equal to 2.324, we have GM is equal to 2.324, GM is equal to 2.324, we have wait a second, we have GM is equal to 2.324, we have WB or W4 is equal to 5%, WB is equal to 5%, we have GB is equal to 1.10, GB is equal to 1.10, we have GT is equal to 2.441, GT is equal to 2.441. Okay, so we have all these things. So let's we calculate first VV, which is equal to GT minus GM upon GT into 100. That is VV is equal to GT 2.441 minus 2.324 upon 2.441. Let's calculate this. VV is equal to 2.441 minus 2.324. Yeah. So 2.441 minus 2.324 is equal to 0.117 upon divided by 2.441. It is equal to into 100. It is equal to 200. So it is equal 0.0479 into 100. That is VV is equal to 4.79%. Okay, let's calculate VB. VB is equal to GM into WB in percentage upon GB. Okay, that is BB is equal to 2.324 into 5% upon GB. GB we have 1.10. Okay, so if we multiply 2.324 with 5, we'll get 2.324 into 5, we'll get 11.62. 11.62 divided by 1.10 divided by 1.10, which it give BB is equal to 10.56 percentage. So we have now VV and VB. Let's move to next page. Give me a second. Yeah, we have VV and VB. Okay, we have VB is 4.79% and VB is 10.56%. Let's calculate VMA. VMA is VB percent plus VB percent. So VMA is equal to 4.79 plus 10.56. So VMA, we'll get VMA is about 15 point something 35%, and VF So we'll easily calculate VF is VB percent upon VMA percent. So VFB is equal to VV is 10.56 upon 15.35. If we do this, divide 10.56 from 15.35, we'll get 0.6879 into 100, obviously. So we get VFB is equal to 0.6879, that is 68.79%. Okay, so we'll get VFB is 68.79%. So our correct answer is 68.79%. So this is it is for this question. Let's move forward to our next question, which is asked in gate 2013 of 2 marks. That is, in compacted cylinder bituminous mix, that is VMA is 15% and VB is 4.5%. The magnitude VFB is, look, we have VMA of 15%, we have VB of 4.5%, and we need to calculate VFB, which is equal to VB percent upon VMA percent. Okay, and VMA percent is equal to VV plus VV percent. So VB percent is equal to VMA 15% minus 4.5%. So 15 minus 4.5 is equal to 15 minus 4.5. Let's calculate 15 minus 4. Minus 4.5%. Okay, and from here we'll calculate VFB. It is something about 10.5%. So VFB is equal to 10.5 upon VMA is 15. So divide 10.5 by 15, we'll get 0.7. Obviously, multiply with it 100. So we'll get VFB is equal to 0.7 into 100. So VFB is equal to 70%. Okay, so that is this option D is correct answer. Okay, let's move to our next question. Oh, yeah, this question is asked in gate 2011. This is again a theoretical question, that in Marshall testing of bituminous mixes, as the bitumen content increase the flow value, then in Marshall testing bituminous mixes, as the bitumen content increase the flow value, as bituminous content increases. If you remember the graph of Marshall method, which is something like this, you know, flow, here it is with flow value and percent bitumen content, percent bitumen, it is something like this, that is increases monotonically. Okay, let's move to our next question, which is asked in gate 2012 of 1 marks. That here it is that two bitumen sample X and Y have softening point 45 degrees Celsius and 60 degrees Celsius respectively. Okay, considering the following statement first is viscosity of X will be higher than that of Y at the same temperature. Statement second is penetration value of X will be lesser than that of Y under standard condition. Okay, as the softening point of Y is great softening point of Y is greater than X, the viscosity of Y is greater than X, that is this statement is wrong, as viscosity of Y is greater than viscosity of X, so that, and due to this also, that penetration value of X will be higher than penetration value of Y, as because in X there is a less resistance to penetrate there. So this option is also wrong. So our correct option is option C. Okay, let's move forward to our next question, which is, yeah, which is this. This is question which is asked in GATE 2010 of 1 marks question. This question is aggregate impact value indicates which one of the following property of aggregate. Look, impact value, obviously toughness. Okay, so this is it. All we all discuss all the previous 10 years questions. So this is it of previous year questions of highway materials. Yeah, this is important previous year question, which is back 10 years question of highway materials. So till then, and then very soon I'll discuss you the previous question of geometric design, and very soon I'll discuss you the traffic engineer numeric portion and that previous year question. So okay, till then, take care. Do lot of practice for your gate examination. Okay, till then, take care. Bye bye. Thank you so much for watching this video. Thank you.